comes to your mind when you hear the word hypoglycemia? According to statistics, every 12th person suffers from diabetes. So if there were 120 people sitting in this hall, statistically speaking, exactly 10 of them would know what we are talking about. But many of you might not have heard about this term, and so I will try to explain to you what hypoglycemia is and why it can be prevented thanks to the research I am participating in. To understanding what causes hypoglycemia, firstly, I must tell you a little something about diabetes. All that we eat disintegrates in our bodies. Part of it leaves our body as a waste material, and part of it disintegrates in the simplest form of carbohydrates, glucose. Glucose is very important because it serves as an energy source for almost all human cells. Glucose travels through our bloodstream, serving as food for cells. But cells themselves aren't very attentive, so they need some kind of helper to notify them about incoming food. This helper is a hormone called insulin. Insulin arrives to the cell, binds to an insulin receptor, invokes a cascade of reactions. This results in the opening GLUT4 transporter and the glucose enters the cell. Simply put, insulin arrives to the door, knocks on the cell, and says, "Hey cell, open the door, dinner is ready." After the cell eats the glucose, it has enough energy and it is satisfied. Unfortunately, it doesn't always happen like this. Such illness called diabetes. The body with diabetes gradually lowers the insulin production until it doesn't produce any at all. So we normally eat, the glucose travels through our bloodstream, but there is no one to tell the cell that it should open the door. This results in the cell not opening the door, being hungry, sad, and dissatisfied, and in too much sugar flowing through the bloodstream. In the end, there is nothing else left to do than supply the insulin with injections. This, however, has drawbacks too. The insulin arrives to a cell, binds to an insulin receptor, and the cell should open the door. But the insulins sometimes forget to eat after the insulin injections, so the cell opens the door, but there is nothing else to eat. So the cell eats the sugar flowing freely in the bloodstream that should be normally inaccessible to it. The sugar levels lowering in the bloodstream, and it might be effect of our organisms, which name is hypoglycemia. As I said in the beginning, there are 10 people with diabetes in this hall. So let's imagine, please, that people shot their insulin shot before the show, but forgot it after it. The first diabetic is going to be irritated. The second diabetic is going to be particularly nervous. The third diabetic is going to be white as a ghost. The fourth diabetic is going to be sick. The fifth diabetic is going to look as he was drunk and the bartender will refuse to him. The sixth diabetic is going to faint. The seventh diabetic is going to fall unconscious. The eighth diabetic is going to particularly nervous. The ninth diabetic is going to fall in coma, and the 10th diabetic is simply going to die. How can we prevent this? The research that I have been part of for over 3 years offers a possible solution. We made small pills in a shape of small balls that after eating release the glucose at the designated time. But why small balls and not just one large pill? There are many reasons. If we have many small balls, we can optimize the dosage for each patient so they eat only as much glucose is necessary for stopping diabetes without overdosing on sugar. The next reason is that many small balls can be easily mixed with yogurt to intake, so the intake is easily, especially for kids. And the most important advantage is that 100 small balls had significantly greater surface that just this one just a little bigger ball, and that make the release of glucose more effective. So the shape and the function are clear. But why can we make it that the sugar doesn't release right away itself, but only when it's actually needed? And it's simple. We coat the sugar ball with coating, and by the thickness, we can determine how long it will to wear off. For example, this coating is just like this bag thin. So it will about 2 hours, and the sugar will be absorbed. On the other hand, this coating is just like this bag, much thicker. So it will take about twice as long for it to wear off. And why do we do all of this research? It often happens that diabetics take their dinner at 5 and then take their insulin shot at 8 o'clock and then goes to sleep. But even in 2 in the morning, the insulin signals to cell should open itself, but at this stage, there is nothing for the body to digest. So the cell begin to eat the forbidden free sugar. But at this stage, where the patients, after the insulin shot, ate a dose of our pellets, then at this stage, when the sugar, being hungry for the forbidden free sugar, our heroic sugar appears on scene and saves the day by preventing hypoglycemia. We have already many samples ready. I brought one with me to show you. It looks like this. We have tested them in labs and everything went well. So we will soon test them on biomodels and hopefully it will be available to common people. And what do you now? Perhaps will be one day thankful that thanks this small ball, you shall not faint.